Howdy, we have a maximizing area problem. It reads, if the sum of the base and height of a triangle is 26 centimeters, what measurements will give the greatest area and what is that area? Let's first sketch a triangle, three-sided figure. Along the bottom we call that the base, and the height is a perpendicular segment going up from the base to the vertex, and that's the height. What's the area of the triangle? It's 1/2 base times height. Let's pick a variable. Let's call it x is the length of the base. And if x is the length of the base, then how can we represent the height using that variable x? Well, it adds up to 26, both the base and the height, so the length of the height would be 26 minus x. 26 minus x is length of height. And our function then, in terms of x, would be 1/2 base, and our base is x, and our height is 26 minus x. And we have a function that is in terms of just a single variable x. And we can simplify that. Let's distribute. What 1/2 x times 26 is 13x, and then minus 1/2 x squared. And let's put that in standard form. That would be minus 1/2 x squared plus 13x. Let's sketch what this would look like. Notice that this is this function is quadratic, and with a negative it will be a parabola that opens down, and we're interested in the maximum value for a of x that occurs at the vertex. We have a couple of ways to represent the vertex. One is if we could put our function in this following form: a equals x minus h squared plus k. The h and k tell you the x and f of x value of the vertex. But a more simpler way is to just use minus b over 2a for the value of x, and the function value, you just replace that x value in for the function. So let's do that. And so we want to take our, we want to take our a is the negative 1/2 and b is 13. So we replace that, negative 13 over 2 times negative 1/2. That's equal to negative 13, and what's 2 times negative 1/2? That's negative 1, and the whole thing simplifies down to 13. And so 13 would be the length of the base, which would give us the greatest area because that's the x-coordinate of the vertex. So the length of the base is 13 centimeters. And then what would the height be? Well, remember the height was nothing more than 26 minus 13, so the length of the height is equal to 26, subtract 13, and that is equal to 13 centimeters also. So we have the length and the height, and now what is that maximum area? To find the maximum area, we can just replace x with 13, and 1/2 base times height is 13 times 13, and 13 times 13 is 169. What is 1/2 of 169? That is, I believe, 84.5. So 84.5 will be the greatest area. The greatest area is 84.5, and that's in centimeters squared. That does it for this time. See ya.